Simplifying Expressions, Part 2. In the last lesson, we went over 3 of the 4 rules for simplifying expressions, also called the order of operations. In this lesson, we are going to introduce the remaining rule in the order of operations, and, in doing so, go over exponents and absolute value. Then we'll solve some problems using all 4 rules in the order of operations to finish up the lesson. So far we have Rule number 1, simplify parentheses or other grouping symbol first. Rule number 2 will be covered later in this lesson. Rule number 3, do all multiplication or division, reading from left to right. And rule number 4, do all addition or subtraction, reading from left to right. Before we add the remaining rule to our list, let's do one problem for review. Let's simplify the expression 4 divided by 2 times 5 plus the quantity of 3 minus 5. The first thing I suggest we do is rewrite subtraction as adding the opposite, to get 4 divided by 2 times 5 plus the quantity of 3 plus negative 5. As the order of operations tells us, we simplify what's inside the parentheses first. So we start by adding 3 plus negative 5. The signs are different, so we subtract the smaller number from the larger number and use the sign of the larger number. 5 minus 3 equals 2, and because 5 is negative, 3 plus negative 5 simplifies to negative 2. This leaves us with 4 divided by 2 times 5 plus negative 2. Since there are no longer any grouping symbols, we move on to the third rule in the order of operations, and do any multiplication or division, reading from left to right. The first thing we come to is 4 divided by 2. So we divide 4 by 2 to get 2. And we are left with 2 times 5 plus negative 2. Notice that if we had simplified the multiplication before the division, we would have gotten the answer wrong, since we would have multiplied 2 times 5 to get 10, and this would have left us with 4 divided by 10 plus negative 2, which is very different from the correct expression of 2 times 5 plus negative 2. Remember, it's multiplication or division, whichever comes first, as we read from left to right. We still have multiplication, so we multiply 2 times 5, which equals 10, and we are left with the expression 10 plus negative 2, which equals 8. The remaining rule that we need to discuss fits right between the rule on grouping symbols and the rule on multiplication and division. This second rule in the order of operations tells us to simplify all exponents and other special operations before moving on to multiplication or division. Now, I realize the first 2 questions you might have are, what the heck are exponents? And what are special operations? So before I give you some examples using the second rule in the order of operations, let's first go over what exponents are all about. And then I'll give you an example of another kind of special operation. When you are texting your friends, do you write out the expression, by the way? Or do you just type BTW? When you are texting laugh out loud, do you type the entire expression? Or do you just type LOL? My guess is you probably use the shortcut. Well, exponents are very similar. They are used to shorten what we are saying. For example, instead of writing 2 times 2 times 2 times 2, why not just write 2 to the 4th? Instead of writing 3 times 3 times 3 times 3 times 3, why not just write 3 to the 5th? Those little numbers next to the 2 and the 3 are called exponents, and they are nothing more than indications of how many of the base number we are multiplying together. 2 to the 7th means we have 7 2's that are being multiplied together. 2 is the base number, and 7 is the exponent. 5 to the 6th means that we have 6 5's that are being multiplied together, and in this case, 5 is the base number, and 6 is the exponent. 7 to the 1st means that we have just 1 7, so 7 to the 1st just equals 7. By the way, when we have something raised to the 2nd power, such as 4 to the 2nd, the shorthand way of saying this is 4 squared. When we have something raised to the 3rd power, such as 2 to the 3rd, the shorthand way of saying this is 2 cubed. Therefore, 4 squared equals 4 times 4, or 16, and 2 cubed equals 2 times 2 times 2, or 8. Now, before we move on, how about trying some exponent problems on your own? Welcome back. Now that we've gone over exponents, let me give you an example of another kind of special operation, and one that you may have already heard of: absolute value. The absolute value of a number simply tells us how far away the number is from 0. For example, the absolute value of 3 is 3, because it is 3 steps away from 0. The absolute value of -3 is also 3, because it too is 3 steps away from 0. What about the absolute value of -10? Well, it's 10, because -10 is 10 steps away from 0. How about -2/3? How many steps is it away from 0? The answer is 2/3, and this explains why the absolute value of -2/3 equals 2/3, which, by the way, is also the absolute value of +2/3. Now, there is one more item to discuss when referring to absolute value, and that is how to write it. The absolute value of a number is designated by using 2 bars, one on each side of the number. For example, this symbol means the absolute value of 4, and this symbol means the absolute value of -4. Both of these expressions have a value of 4, because both 4 and -4 are 4 steps away from 0. Okay, now let's simplify a few expressions using all 4 rules in the order of operations. Remember to start with parentheses or other grouping symbols, then simplify any exponents and special operations, then do any multiplication or division, reading from left to right, and lastly, complete any addition or subtraction, reading from left to right. You may want to click the pause button so you can look over the rules before we start. Here's our first problem: 2 cubed plus 3 times 5. We start by rewriting any subtraction as adding the opposite. There's no subtraction, so nothing to rewrite. Remember, the trick of rewriting subtraction as adding the opposite isn't a rule in the order of operations. I've placed it above the list just to help make things look a little bit clearer. Okay, so on to the order of operations. There are no parentheses or other grouping symbols, so we look for exponents. We have 2 cubed, and 2 cubed equals 2 times 2 times 2, which equals 8. So we have 8 plus 3 times 5. There are no more exponents, so we move on and perform the multiplication before the addition. 3 times 5 equals 15, which gives us the expression 8 plus 15. And 8 plus 15 equals 23. So we have 23 as our answer, and we're all done. Now let's crank it up a notch and try this problem. 3 squared minus 9 divided by 3 times the quantity of 1 plus 2 cubed plus the absolute value of -2. First, we rewrite subtraction as adding the opposite to get 3 squared plus -9 divided by 3 times the quantity of 1 plus 2 cubed plus the absolute value of -2. Now we follow the order of operations, which tells us to simplify the inside of the parentheses first. Inside the parentheses, we see that we have an exponent, so we start there. 2 cubed equals 2 times 2 times 2, and 2 times 2 times 2 equals 8. So we are left with 1 plus 8, and 1 plus 8 equals 9. This gives us the expression 3 squared plus -9 divided by 3 times 9 plus the absolute value of -2. We've eliminated the parentheses, so we move on to the second rule in the order of operations. Simplify any exponents and special operations. We have 3 squared, and 3 squared equals 3 times 3, or 9. So we have the expression 9 plus -9 divided by 3 times 9 plus the absolute value of -2. Good. All of the exponents are gone, but we still have an absolute value. So let's deal with that. The absolute value of -2 is 2. So the expression simplifies to 9 plus -9 divided by 3 times 9 plus 2. Now we move on to our third rule and do multiplication or division, whichever comes first as we read from left to right. The first thing we come to is a division problem right smack in the middle. So let's simplify that. -9 divided by 3 equals -3. Remember, we get -3 because the signs of -9 and 3 are different. So our simplified expression is 9 plus -3 times 9 plus 2. We still have a multiplication problem, so we multiply -3 times 9 to get -27, and we are left with 9 plus -27 plus 2. Finally, we can use the last rule in the order of operations, which tells us to add or subtract, whichever comes first, as we're reading from left to right. The first problem we come to is 9 plus -27. We are adding numbers with different signs, so we subtract the smaller number, 9, from the larger number, 27, to get 18. And because 27, which is the larger number, is negative, we put a negative sign on 18 to get -18. Now we have the expression -18 plus 2. Again, we are adding numbers with different signs, so we subtract 18 minus 2 to get 16, and then take the sign of -18, which is negative, so we get -16 as our answer. So the simplified form of the expression, 3 squared minus 9 divided by 3 times the quantity of 1 plus 2 cubed plus the absolute value of -2 is -16. Nice! Notice how difficult this problem looked at the start, but all we did to simplify it was go through our rules one step at a time. Now might be a good time to bring up something that you may see and perhaps have already come across. People will often suggest that you remember the order of operations by memorizing something like, "Please excuse my dear Aunt Sally," or PEMDAS. This saying is supposed to help you remember the correct order of the rules. P stands for parentheses, E stands for exponents, M for multiplication, D for division, A for addition, and S for, you guessed it, subtraction. The problem with this little saying is that it almost forces you to forget one of the most important parts of the rules. Do multiplication or division, whichever comes first, and then do addition or subtraction, whichever comes first. Because PEMDAS always has the M before the D, you might think that you should always be doing multiplication before division, and this is wrong. Likewise, having the A before the S might give you the impression that you should always do addition before subtraction, and this is also wrong. Remember, it's whatever operation comes first as we read from left to right. For example, if multiplication comes before division, such as in the problem 3 times 2 divided by 2, we simplify the multiplication first. If division comes first, such as in the problem 2 divided by 2 times 3, we simplify the division first. Okay, back to work. Let's do one more problem and then we'll call it a day. Here's the problem. Simplify the expression, the quantity of 2 plus 2 minus 4 times 3 divided by 4 times 2 plus 3 squared. This one tests all of our steps, and it looks tough, but as we have done in the past two examples, let's attack it one step at a time. Before we get started, let's rewrite subtraction as adding the opposite, to get the quantity of 2 plus 2 plus -4 times 3 divided by 4 times 2 plus 3 squared. Notice that I've been very careful to copy down the parentheses in this step, and I'll make sure to copy the exponents and negative signs in the next steps. We really don't want to get the problem wrong just because I made a simple copying mistake. So we start at the top of our list and simplify parentheses first. 2 plus 2 equals 4, so we have the expression 4 plus -4 times 3 divided by 4 times 2 plus 3 squared. Okay, let's move on to exponents. 3 squared equals 9, so we get 4 plus -4 times 3 divided by 4 times 2 plus 9. Now we move on to our third rule and do multiplication or division, whichever comes first. As we read from left to right, the first multiplication or division problem we come to is -4 times 3. The signs of -4 and 3 are different, so we multiply -4 times 3 to get -12, and we are left with 4 plus -12 divided by 4 times 2 plus 9. we still have both multiplication and division is next. So we divide -12 by 4 to get -3. And now we have simplified the problem to 4 plus -3 times 2 plus 9. There is still one more multiplication problem. So let's multiply -3 times 2 to get -6. And this leaves us with the expression 4 plus -6 plus 9. Finally, only addition remains. So we add up the numbers reading from left to right. 4 plus -6 equals -2, which gives us the expression -2 plus 9. And this simplifies to +7. I'm going to say it one more time because it's important that this is clear. Although this was a tough problem, all we had to do was go through the order of operations step by step to get the answer. Okay, nice work. In this lesson, we introduced the remaining rule in the order of operations and also talked about exponents and absolute value, which is a type of special operation. We finished up by simplifying a few problems where we needed to use all 4 rules in the order of operations to get to our answer. Before calling it a day, I'd like you to try some problems on your own. One word of caution though. One of the mistakes that students often make when simplifying problems, or solving any type of problem for that matter, is the simplest thing of all. They aren't careful when copying from one line to the next. They might forget to include a minus sign, or leave out an exponent, or even change a number altogether. That's why it's important to be careful and take your time. It's never fun to get an answer wrong just because you wrote minus instead of plus, especially when you know how to do the problem. Good luck!